So let's get started. Yesterday we started with a small web API, and let me quickly show you again what we did, and then we will dive into the next topics here. Let's take a look at the very first API endpoints here. Was these endpoints here. Remember, this was the HTTP method, get in this case. This was the URL path. It's matched against the incoming URL, and then ASP.NET Core will call the proper handler here. This is a handler, and it's just a Lambda function. We'll discuss Lambda functions during this course over and over again. I think this was pretty clear. The next level was this one, where we had on the one hand side a query string parameter, which you see here, and a path parameter, which you see here. This was that one's, and here we just combined both. We have the ID, which comes from the path, and we have the options, which come from the query string. Nice, looks good. And then the last example was the post example, where I just demonstrated to you how we can handle a post request and how we can work with records. I told you that records are a great match for ASP.NET Core Web API because records are very easy to write. They are behind the scenes classes, but for us it's really convenient to write like that. So that was what we did yesterday. What didn't we control so far? We handled query string parameter, we handled path parameter, and we handled the request payload. Now we didn't handle the response payload property. We just sent back strings, as you can see it here. We never used JSON here. And we didn't handle HTTP headers and status codes, right? And this is exactly what we are going to do today. Could you please close the window again? I think it was good enough. Now we have nice enough oxygen here in the room. That is good. The first thing that I would like to show you is how to control the status code that we return. Okay? For that, we are going to add another route. Please follow me in creating another route. app.map_post. And we are going to tell it, I am happy. And if we say I am happy, we can use the results class here. And here you see all the different API status codes. You don't have to know the numbers from the top of your head. You simply select the topic that you would like to return, the status in form of text. For instance, if we are happy, we can return OK. By returning results.OK, we are returning a status code. Hover over with the mouse, 200. See? Now if we copy this guy and we say I am unhappy, we can, for instance, return a bad request. Something like this. Yep, everything's good? Very good. Now, if we copy it again, we could say I am happy and I will tell you why. Then we can, for instance, say, because it's Friday. I think you get the idea, right? We can return an error information by simply specifying the error data inside of the results function, as you can see it here. Got it? Let's try it. Oh, I did a mistake. I didn't want to do post. I wanted to get, so please change that to get. I'm sorry, I did something wrong here. And if you have that, you can try it. Run it by running the debugger. And that I am going to use my, my REST client again. If you want to use Postman, I told you that already yesterday, you can do that. Absolutely no problem. So we say get. Let's copy the host name from up here. Good, here it is. I am happy. And if I run it, I get back a 200 OK. See? If we say I am unhappy and we run it again, we get a 400 bad request. See? Here. And if we say I am unhappy and I will tell you why, that was a long URL. I will also get back the additional data information. Obviously, you do not need to return just a string. You can return more elaborate response data, maybe an object or something like this. If you want to transmit more information than just a string, that's a good idea. There are even standards for that. There is an RFC, I think it's 7807 or something like this, that defines in detail how a REST API should respond in case of error. But hey, for now it's perfectly fine. Does it work for everybody? Do you get the proper response codes? Do you get the proper response payload? So remember the results class. Next, I would like to not receive a customer through the request payload, but I would like to return the customer in the response payload. Let me show you how that looks like. App.mapGet, and here we say now, no, forget what I did now. We will change that up here. We already have a route which says customer ID, but now that we have a customer, we can easily return a customer, okay? So how do we do that? We do that exactly here. Instead of the string here, we are going to return a new customer, and here we specify the name, that's foo, the company, that is bar, and the age is 42, something like this. It's as easy as that to return an object which will automatically be converted to JSON properly. Let's give it a try. Run it. And this is a get, so I can try it in the browser. Customers, 99. And you see, we get back JSON. The uppercase characters at the beginning of the property names are automatically converted to lowercase letters in the JSON fields. So this is done completely automatically. And this can be a really complicated object. It could be an array. It could be an object which contains an array or a list. It could be nested objects, whatever you want to do. Just return the object and you're good. Of course, we can bring these two concepts together. Instead of returning new customer, we can also say results.OK new customer. With that, we can not only return the customer, but we are in full control over the status code. We say status code 200 and return the customer. And if we don't want to return OK, but if we want to return whatever bad request, we can do that and still return the customer. It doesn't make sense content-wise, but I think you get the point, right? Do you see how useful these records are? You can use them for decoding the incoming request payload, and you can use them for encoding the response payload. And they are so easy to write, and they are really easy to use. Please try it and let me know if you have any problems. If your application grows larger and larger and larger, you will at one point in time have a lot of these handler functions. Not just 5 or 10, but maybe dozens, maybe hundreds, maybe thousands in larger applications. So this will probably not be a good idea to put all of them in a single file called program.cs. And even if you have more complicated API handlers, just write everything in a single Lambda function. That is not a very good idea. So let's try to extract this stuff a little bit into separate functions. Let me show what I mean. I would like to create a function, a helper function down here. And let's keep it very, very simple by saying string get congs name, something like this. And here we simply say return Kong, okay? Please use your imagination. In real world, you would have more complicated code here. But I'm now really trying to focus on the very basics of API development. Good? So in real world, of course you don't write something like this. Here you will have multiple lines of code. But I think you get the idea. And now let's see what we can do with that. Now that we have this function down here, we can easily replace this Lambda function just by the name of the function we would like to handle the API request. See? Instead of specifying a lambda function, we simply specify the name of the function. Please note that we do not call the function. That would be wrong. Just specify a reference to the function. So the router knows it has some kind of function pointer behind the scenes, and the router knows which function to call whenever the request king comes in. Give it a try. Run it. And hopefully it will still work. Here we can say king and we get back Kong. Our app still works flawlessly. Try it. Okay, now that we have our web API handler in separate functions, we can of course put these functions into separate files. No question about that. So what we can do, once our application grows larger, we can simply add a second file. Let's say, I don't know, myhandlers.cs. Well, obviously, you would use a more expressive name in real-world applications. You wouldn't call it myhandlers. You would call it something like customer management handlers or user management handlers, or you have multiple files depending on how you structure your application. Here you can use all your existing software engineering skills that you have gathered over the years. Okay? So what do we do here? First, we typically specify a namespace, hello ASP.NET Core, something like this. Then you specify a class, public class myhandlers. And inside of the class, you can now add your functions. But these functions should be static functions because we are not in the world of classical web development. We are in the world of API development. And there we just have functions. So we can even, sorry, I forgot that one, make this one a static class. And then specify here a public, static. And now we can simply go back to program.cs and copy this getCon's name. Copy it here, string, something like this. Now this is a function, static function, inside of a static class. And now we can go back here, and instead of writing getCon's name, we can say here, my handlers. This is in the hello ASP.NET Core namespace, and here we have this function. See? So this allows me to move my functions into separate files. Is everybody aware what this static means here? Somebody not aware what this static means? Nice, very good. So you all know what static methods are. Good, I like that. So that is how you can structure your application. You can write all your handlers and then create multiple files and put those handlers into static classes and structure it accordingly. Does it make sense? Clear so far? Yes, question.
Something that didn't work on you.
Okay, I will come and we'll take a look. Now some of you are having problems because Visual Studio Code is telling you that there is already a class myhandlers. That's your problem. That was your problem. Some having problems because Visual Studio Code is screwing up IntelliSense after creating a new class. I am super sorry. I have to apologize. It's not our fault. That's the fault of Visual Studio Code in combination with C#. There is a slight bug that leads to this very annoying behavior. You can get rid of it by pressing the F1 key that opens up the command palette here on the top of Visual Studio Code, and then simply type in restart. I mistyped it. Restart, and there you will have a command which says OmniSharp, restart OmniSharp. What is OmniSharp? OmniSharp is the component that cares for IntelliSense and all this stuff. And sometimes this OmniSharp simply dies or does something wrong. And if it is kind of strange, the behavior of Visual Studio Code, the first thing that you should do, and again, I'm sorry for that, is restarting OmniSharp. For a second, you will lose some features in Visual Studio Code, but a few seconds later, everything should be okay, and you should see that the errors should have been gone. Does it work? Yes. Does it work? Yes. Does it work?
No.
No. Okay, so you might have a different problem. I'm going to check it. So that was just a problem of not being patient enough. Now you have IntelliSense again. Good. Good, good, good. Any questions so far? Clear? Nice. Very good. Now let's step up the game a little bit. Let's try to extract this one into a separate method. I'm going to simply add the method here at the beginning. Well, the implementation is really critical, really trivial, sorry. I can say something like, I have no idea what I will say here, return OK, and this will simply say return results.OK. This one is simple. But what is the return type of this function? What do you think? Is it a string? No. How can we find out what the return type is? Well, we can simply hover over this OK here. And if we take a close look, then we see that all these resulting methods, they return an interface, which is called iResult. And this is exactly the return type that those methods typically have. iResult. See? iResult. And this is something that you have to remember. I think it's not that complicated because it's the result of the API. So remember just the word result, and then you can look it up very quickly. If you have something like this, you can now replace the lambda with the name of the function, and everything is okay. Visual Studio Code is happy, C# is happy, we are happy, everything works. Try it. And remember what we did in the last few months about Angular. Now it would be very, very simple to build an Angular application which consumes exactly that API. That's the whole idea. That is why we do that. By the way, just a quick note on the side. We would need to master two different programming languages here if we use that in practice. If we use C# on the back end and Angular on the front end, we have to mix C# and TypeScript. And in our mind, we have still always to switch between C# when we do back-end development and TypeScript when we do front-end development. If we don't want to do that, if we just want to focus on a single programming language, is there a way to do back-end development in TypeScript? We had it yesterday. Yes, absolutely, with Node.js. You can use Node.js and Express, and then you can do full-stack JavaScript development. But now comes the difficult one. Is it also possible in C#? Can I do back-end C# development and browser development in C#? So do I have an alternative in C# to Angular, for instance? Oh yes, you have. And it's one of the most fascinating pieces of technology that currently exists in the Microsoft universe. It's called Blazor. Blazor. B-L-A-Z-E-R. Oh, it's so good. O-R, not A, E-R. Yeah, you know what I mean. Just Google it. You will find it. It works really, really, really good. It's really exciting. And if you want, maybe we have time this semester, we can take a quick look at Blazor. It is based on WebAssembly. I don't know if you have ever heard of WebAssembly. Blazor is based on WebAssembly. And the beautiful thing is that it works completely in C# and you have never to touch JavaScript again. Well, that's not 100% true. But for most cases, you can really forget about JavaScript, write C# everywhere, and it works like a jar. It's very widely used in practice because there are a lot of C# developers out there who dislike JavaScript. I don't know why. JavaScript and TypeScript are great languages, but still they don't like it, so they like C# more, and therefore they use Blazor instead of something like Angular. But that was just a note to the side. In this school, the entire school decided to do Angular for front-end web development and C# for back-end web development. It is like it is. But still, you should have heard this term before. Good. You know what? I would now like to put all these things that we just practiced into a larger sample. Let's build a tiny little API that does something useful, where I can add certain elements to a list, where I can query the list, where I can get elements by ID, where I can delete elements by ID, where I can maybe update elements. Good? Let's try that. Nice. It's completely up to you whether you want to start a new project and store this one for your archive. I would rather recommend that. So I would say keep this project just for your reference. Maybe you will need it during the exam or homeworks, and start a new project on your computer. Remember how we started a new web API project? Just to quickly recap, it's .NET New Web. This is how you started a new API project. It's .NET New Web. What do you want to maintain? A list of what? Customers, books, orders, jokes, heroes, movies, songs. Tell me something. What are we going to maintain?
Jokes.
Jokes? Let's do jokes. Okay. Let's do jokes. Dad jokes, right? I'm not very good at telling jokes, so I need your jokes. But I think if we Google dad jokes, we should not have a problem here. So, the first two lines should remain the same. Maybe we'll leave one map get up and running. And you can, if your application is new, you should have something like this on your screen. I will, the myhandler.c# can also be removed. So I will wait a second until everybody has created a new web API project, and it will be the joke manager, the joker, right? Yeah, like that one. Good, so let's get going with the joke manager. The first thing that we definitely would like to design is how the routes will look like. So what I'm going to do, just for a quick design decision here, let's note in a comment section the API routes. How are we going to define our routes? I would say the first one is get jokes, and that should return a list of all jokes. Okay? Makes sense, right? Note that I'm using plural here, jokes, not joke, because it returns a list of jokes. We could say get joke, and then the ID returns the details of a single joke. Makes sense, right? Of course, jokes, again, plural, and with the ID at the end, we are referencing a single record. Can you remember when we used Airtable? They followed exactly the same concept here. We had heroes, and then we used the ID. So we are rebuilding what we have learned there. How could we add a new joke? With post jokes adds a new joke. How can we delete the joke? Delete jokes with the ID. Deletes the joke with the given ID. Delete. And last but not least, we have to decide whether we do put or patch. And to keep things simple, we are going to focus on put. So we replace the entire joke. Jokes ID replaces the jokes data. Something like this. What we just did here is API design. And that is super, super important. Believe me, in larger projects, this is not a trivial task. If you have hundreds or thousands of APIs, then you have to think hard about how you name your collections. What APIs do you want to offer? What will be the query parameters? What will be the headers? That is not simple. If you want to take a look at a large API, you can take a look, for instance, at the API of Kubernetes. Did you do some Kubernetes stuff already in other? No? Okay, then that's not a good idea. You can take a look at the API of projects like Slack, or you can take a look at the Microsoft Graph, which is also a very, very big API. In the past, you could take a look at the Twitter API, but it's going to be liable to costs in the future, so this is not a good idea anymore. You can also take a look at the Pokey API or the My Little Pony API and learn from them. But they are not so large. Good. The last thing that we need to think about is how will a joke look like? So structure of a joke. I think we can safely say that a joke has an ID, right? You can say an ID. This is the ID of the joke. The question is, with an ID, who generates the ID? Will the one who creates the joke also create the ID, or should we create the ID on the server side? Understand what I mean? If you use the database in the background, the database will create the primary key for you. Get the idea? Did you want to make a comment?
Yeah, I want to say something.
Okay, so for us, we can say ID of the joke, and we can say generated on the server side. We don't have a database yet. That will come later in this semester. But for now, we simply maintain everything in memory. Then we have the joke text. This will be the text of the joke, of course. And then maybe what could we also add? We could add a fun level, okay? And that is an integer describing how funny the joke is. Values 1 to 5, for instance. Or 0 to 5. 0, not funny at all. 5, hilarious. See? Things like that. These thoughts about how is my data structure looking like and what are the API routes, this is something that you have to think about before you start coding. And this is completely independent from the programming language. If you would build your API with, I don't know, Go or Rust or Express, it really doesn't matter. These are the thoughts that you have to invest. How do I structure my API? What is the payload? And now we have a plan, right? Now we can follow this plan. Good. Let's get started. Our API is really, really simple. So it's perfectly fine in our API, right? It's perfectly fine to keep everything in the program.cs file. I would say in the first few weeks of our course here, when we do ASP.NET Core development, the applications will be so small that it's perfectly fine to put everything in program.cs. As long as program.cs is not longer than, let's say, 200, 300 lines, something like this, it's perfectly fine to keep everything in a single file. But for larger projects, for your final year project, for your 2-year project that you are going to do, you will definitely need to think about how to structure your application, because you will have way more code. But we are at the beginning, so let's keep it simple. Okay? Good. So let's think about the API routes. What I like to do is I like to set up the different routes before I implement them. So we have a plan up here, so we can easily set up the routes here. We can, for instance, do the following. We can say map get jokes. This is that one here. Let me finish this line, and then we'll do the break, okay? It's just this line up here. And here, instead of hello world, I'm simply going to say throw new not implemented exception. That is just a note for me. Sorry, you have to use curly braces in this case. Something like this. That is just a note for me that is, as the name suggests, not implemented yet. It's a kind of to-do for me. See? It's a to-do item. And then I can follow along I can go next line, I copy it and say, I will have the ID. This is what we have to implement. Then we have a map post. And that is also to the jokes here. Then we have a map delete. And that is, again, something like this. And finally, and then we are done, we have the map put, which looks exactly the same. See? Now we have set up the routes for our tiny little API according to our plan up here. And we didn't bother thinking about how to implement the things. Now we can go upon it to implement handler by handler by handler. That's a good strategy. Always have a plan, then try to implement your plan step by step. Now I laid out my API routes, and now I can dive into the details. Any questions so far? Good. So I think we have reached a very good intermediate step in our tiny little project. So I think we can make a break now, and after the break we are going to implement the different API routes.